we go. Just example 1. Okay, so if we turn to page 202, they have these notes. So we looked at this already. Oh, this one's interesting. Look at 3x squared plus 12 equals 0. We got the x squared by itself. And then the next step would be, how do you get rid of squared? Square root both sides. But what's the problem with this minus 4? Can't square root it. This one has no solution whatsoever. The answer to this is that there is no answer. Okay? But sometimes you don't have little boxes, so I'm not going to give you the little boxes. We are going to highlight this. Okay? They use a strategy called completing the square. I call this strategy solve by square rooting. And you can only use the solve by square rooting when you have your x in something squared equal to some number, right? We saw that it didn't work if there was an x on the other side, because when we square rooted the other side, we're like, oh, I still have that x inside the square root. So the solve by square rooting uses something called completing the square, and the reason they call it completing the square is because you need to have something squared in order for it to work. So here is the question, and we're not going to look at their little boxes because it's not that helpful. I have x squared plus 6x, and on the other side I have 16. What do I want? I want something squared equals something. The 6 is the hint. What would have to be here? Squared. It would have to be an x to get the x squared, right? But what would have to be in here? If you multiplied it out, that would give you the 6x. You said it already? No, not square root of 6. Right? Think about, this is what you have to think about. Where do I have space? I will make space. A3. There we go. Right? I'm going to guess it's going to have to be a plus to get a plus 6x. Does that make sense? And someone's putting 3. Why 3? Because now my outside and inside will be 3 and 3, giving me the 6. So I know this needs to be a plus 3. But then the problem is there would need to be a number there. And if you think about it, what number would need to be there? 9. Plus 9. But if I add 9 to this side, and not the other side, that doesn't make my equation equal anymore. So if I add 1 to one side, I have to add 9 to the other side. Does that make sense? And if I get it to look like this, now I can use by solve by square rooting. Because you could square root both sides. Oh, I'm disappointed in this question. Because it's a nice number. I wanted a not nice number. Because with the nice numbers, it means, oh, I could have factored. And factoring is way faster than solve by square rooting, if you can factor. What's the problem is there's lots of times you can't factor. And then we need this other technique. So if I move the 3 over, negative 3 plus 5 would be 2, and negative 3 minus 5 would be negative 8. Those are my two answers. And this method I call solve by square rooting. A lot of people use this completing the square because this to this, you had something that wasn't a perfect square and you had to complete it by adding the 9. So that's where the words completing the square come from. What do we have to do, mental math-wise? We have to be really good at foiling things out. There is a pattern that always happens from this number to this number. I'm not going to tell you what it is. You have to, I don't know, you're going to have to see if you can brilliantly figure out what it could possibly be. You have to put up your hand, and you say it out loud, then I don't want that. No. You're going to have to, there is like, with this one, we had 6x, we had 3. What was the other one I did before with you? Oh, I did this one here. It was a 4x, and this number was a 2. I'm not going to say how we figure that out. We're just going to do another example. We'll go to example 2. Here we go. It says, oh, it's a 4. We already know the 4 one. Should we just make a new question? Mm-hmm. Let's make it 8, just for fun. To see if you figure out what the pattern is. So if we want to solve by completing the square, if we want to solve by square rooting, we want something squared equals a number, right? Because then we can square root both sides. So as far as there's steps I could write out for you, but if you know what you want, the steps become obvious, and then it's easier to remember, okay? So I could tell you that step 1 is move the 3 over to the other side. But if you know you want something squared equals a number, it kind of makes sense that you want the number on that side, right? Then I want something squared. This is a plus. Does it make sense that this will be a plus? And now you have to imagine 2 things, and you need to get an 8x. Any guesses? What do you think should be there? A 4. Oh. But if there was a 4 there, I often take out a different color pen for this. Some teachers say, move the 3 over, then make a space on both sides. But I like to do this part first, because this is what we wanted. But if I have x plus 4 squared, there would be a number here. What number would be there? 16. And if I added 16 to this side, in order to keep it equal, does it make sense I'd have to add 16 to that side? Our number's not going to match the bottom, right? Because we changed it to an 8. But what would you do next? Now you've got something squared. This was our goal, right? Why did we want to get this? Because then we could square root. Don't forget the plus or minus. Move the 4 over. And we get -4 plus or minus the square root of 19. Yes?
Would be a wrong answer instead. Plus or minus square root of 19 take away 4.
No. But we get into the process of writing it this way more often. Intuitively, I think makes more sense to put it at the back. Okay. What are some of the reasons it's not done that way? For one, is some students do this. A square root got a little bit too long, right? It should just be there. That's better. But then sometimes, like, okay, should I take off a half mark to that? Is that too far for that square root? Like this, definitely I'd take off, like maybe probably a whole mark. That is way too long. It definitely looks like that -4 is under that square root, in my opinion. Okay? You're like, no, that -4 is after. No, it doesn't look that way. So then, still a mark, still a mark, still a mark. Ooh. Still a mark? You take a mark off for that? Yeah. Half? 3/4 mark off? Right? 5/8 maybe? So, part of the reason the 4 is in front is that it avoids issues like that. And then when we get to our quadratic formula, you'll see that in the quadratic formula as well. But if you wrote it like this, and you made sure your square root wasn't too long, it's perfectly fine. Okay. Questions for this one? Circle 5, 8, and 9.